In this video, we will learn how to find areas under the normal curve below or above a given z-score and between two z-scores. In this video, we will be having three cases. Case 1 is we are going to find areas under the normal curve below a given z-score. When it is stated as below a given z-score, it can also be said as less than the given z-score or at most the given z-score. Let us have our first example. Find the area less than the z-score 1.37. This is our standard normal curve, and the z-score for example number 1 is 1.37. Let us locate it. Let us say that the z-score is located here. It's 1.37. And let's draw a vertical line. Example 1 is wanting us to determine the area less than or below the z-score 1.37. That means we will be looking for the entire area below the given z-score or this area that I am shading. Now to do that, we have to express this first as a notation of probability. We determine the probability or the area under the normal curve when the z-score or less than the z-score 1.37. And we can do that by determining the area when the z-score is 1.37 above the mean plus. As you can see, now to determine the area below the given z-score, it requires us to determine the entire area, which includes the 1/2 of the normal distribution. Remember that one of the properties of our normal curve is that it is symmetrical. That means the area below the mean is 50%, or that is 0.5,000, and the area above the mean is also 50% or 0.5,000. Now the problem wants us to determine this entire area. If that is the case, we will look for the area of the normal curve when the z-score is 1.37 and plus the area which is 0.5,000. That is the area of the first half of the normal curve. We have here, that is 0.5,000. Now, we simply determine the area of the normal curve when the z-score is equal to 1.37, and we will be using our standard normal curve areas table. Again, when the z-score is 1.37, then the area is, we have 1.37. The area is 0.4147. That is 0.4147. 4147 plus, that is the area of the half of the normal distribution table, normal distribution curve. Okay, and we have now the probability or the area to the left of the z-score 1.37 is equal to the sum, which is equal to 0.9147 or again, express this as a percentage that is equal to 91.47%. In other words, the area below or less than the z-score 1.37 is 91.47%. We determine that by adding or summing up the one half of the area of the normal curve, which is 0.5 thousand, or that is 50%, plus the area when the z-score is 1.37, and we got that is 0.9147 or 91.47%. Let's have our example number 2. How about when we are asked to find the area below the z-score, which is a negative z-score. In this case, we have negative 2.09. In our normal curve, let us locate this z-score. It's below the mean. Let's say it is located here. And since it states that it is below the given z-score, then we are asked to determine this area. Okay? This shaded portion. Now, to do that, let us first denote this. P is, we are going to determine the area below the given z-score, negative 2.09. And again, the entire area is 100% or 1. Half of it is 0.5 thousand. Now, to do that, we are going to subtract the area under the normal curve when the z-score is equal to 0 or is equal to the given z-score or negative 2.09. That is, again, when we are going to determine the area below the z-score, which is a negative value, in this case, we have negative 2.09, we subtract the area when the z-score is the given z-score, that is negative 2.09, this area, no? Because the entire half area is 0.5 thousand. To determine this area below the given z-score, we subtract the area when the z-score is negative 2.09 from 0.5 thousand. And that is, we determine first, that's equal to 0.5 thousand minus the area when the z-score is 2.09, 2.09, 2.09. We got 4817, okay? 0.4817, 0.4817, and we got the area below the negative z-score 2.09 equal to 0. Okay. Now the area now to the left or below the z-score negative 2.09 is 0.0183. Let us have our second case. The second case is when we have to find the area above a given or greater than a given z-score. Let us have our example numbers 3. Find the area above the z-score 0.36. Now, let's first denote this. We have the probability or the area when the z-score or the area above the given z-score 0.36. Okay, now let us locate this z-score in our standard normal curve. 0.36 is probably located here. Okay, let's say it's here. And we're asked to find the area above this z-score. That means we locate this area, the shaded part. Okay. Now, to do that, remember that this half is equal to 0.5, and we know using our standard normal curve areas table that we can determine this area. And for us to be able to determine the remaining area, we simply do subtraction, because this one, the probability or the area above the given z-score 0.36 is simply the area less or simply 0.5 thousand minus the area when the z-score is equal to 0.36. And let's do that. Equals 0.5 thousand minus, what's the area under the normal curve when the z-score is 0.36? 0.36. There you go. This is 0.1406. 0.1406. And let's have now the area above the z-score 0.36 is equal to, that is 0.5 minus 0.1406. And we got 0.3594. 0.3594. Thus, the area above the z-score 0.36 is 0.3594, or that is 35.94%. That is only 35.94%. This area, this one, okay, above the given z-score. Now let us have our second example for the second case, which is above or greater than the given z-score. Now, find the area greater than the z-score negative 1.07. Let us locate this z-score in our standard normal curve. That is negative, then it is located below the mean, 1.07. Let's say it's located here. Okay, now greater than, that means, or above the given z-score. That means we are going to look for the area, for this area, including the other half. Now, if this is the case, as you know, and obviously, this area is equal to 0.5, and we simply add the area when the z-score is 1.07. Let's denote that. we have the probability or the area above the given z-score 1.07 is equal to 0.5000 plus the area when the z-score is negative 1.07 or 1.07. Okay. Now we have let's have this. We have 0.5000 plus the area given the z-score negative 1.07. Again, we will be looking at the same standard table. 1.07, it's here, 0.3577, 0.3577. And to state our final answer, we have the area above the given z-score negative 1.07 equal to 8.577. Or that is, sorry, it must be 0.8577 or that is equal to 85.77%. How about this is now the area of the shaded region under the normal curve. How about when we have to determine the area under the normal curve between two z-scores? Let's say our example number 5. Find the area between z equals 0.53 and the z-score 3.16. To better understand this problem, let us illustrate this using our standard normal curve. When we have two z-scores, let us locate first our two z-scores in our normal curve. 0.53 may be located here. Okay, 0.53 and 3.16. It's maybe here. Thus, we are going to determine the area between the two z-scores. We are looking for this area. Okay, this area. Now, to do that, we simply subtract the area when the z-score is 3.16 by the area when the z-score is 0.53. Let's do that. Okay, we have, it is denoted 0.53 when the z-score is between or 0.53 and 3.16. That's equal to the area when the z-score is 3.16 minus the area when the z-score is 0.53. And we have, what is the area under the normal curve with z-score 3.16? 3.16. Let's look at we have it here, 3, 0, 1, 2, 3, 4, 5, 6. Am I right? Okay, we are right. That's 3.16. It's 0.4992. Okay, we have 0.4992 minus the area when the z-score is 0.53. We have 0.53, 51, 52, 53, 0.2019. That is 0.2019, and we got the area between the z-scores 0.53 and 3.16 is now equal to, we have 0.4992 minus 0.2019, we got 0.2973. 0.2973, or that is equivalent to 29.73%. When the z-scores are both positive or both negative, we subtract the areas. Example number 6, we have still two z-scores, between two z-scores, and the z-scores now are both negative. Let's illustrate this using our standard normal curve. We have the first z-score is negative 1.25. It may be here, 1.25. And the second is negative 3.33. Here, probably. Okay. Between these two z-scores, what is the area? Okay. Now again, when we have two z-scores, between the two z-scores, and both z-scores have they have the same sign, they are located on the same side of the normal curve, then we will subtract the areas. Let's denote this. We have the area between z-scores negative 1.25 and negative 3.33. That's equal to the area when the z-score is negative 3.33 minus the area of the z-score negative 1.25. Okay. Now, let's put this in one line only. Okay. And we have now, that's equal to, what's the area under the normal curve when the z-score is negative 3.33? Let's look at the normal curve areas, standard table. 3.30, 31, 32, 33. That's 0.4996. No? 0.4996 minus negative 1.25. 1, 20, 1, 2, 3, 4, 5. That is 0.3944. 0.3944. And we have now the area between the z-scores negative 1.25 and negative 3.33. That's equal to, using our calculator, we have 0.4996 minus 0.3944. We got 0.1052. 0.1052, or that is equal to 10.52%. Okay, what if the z-scores, or between two z-scores that are located in opposite side of the curve? One is above the mean and the other is below the mean. To do that, let's illustrate this. Find the area between the z-score negative 0.99 and the z-score 2.24. Let's illustrate that in our normal curve. We got, first is negative 0.99. It might be here. Okay. And we have 2.24, probably here. As you can see, we are looking for the area between these two z-scores. That means we are looking for this area. Okay? Now, obviously, we are going to add the areas in order for us to be able to determine the area between these two z-scores. Okay? We have the area between negative 0.99 z-score and 2.24 is equal to the sum of the area when the z-score is negative 0.99 and when the z-score is 2.24. Let's do that using our standard table. What is the area when the z-score is negative 0.99? 0.99. Here we have 0.3389. 0.3389 plus, when the z-score is 2.24, 2.21234.4875. 0.4875. And let's state our final answer. We have now the area between the z-scores negative 0.99 and 2.24 is equal to 0.3389 plus 0.4875, and that's equal to 0.8264. 0.8264, or that's equivalent to 82.64% of the normal curve. That is how we are going to find the area between two z-scores when one of the z-scores is below the mean while the other is above the mean. Let's go back. We have three cases. The first case is when the z-score, or when we are asked to determine the area below the given z-score or less than or at most the given z-score. If that is the case, just like example number 1, we are going to add the area when the given z-score and the half of the area of the normal curve, which is 0.5000. However, that happens when the z-score, given z-score, is above the mean. That is positive. Because if it is below the mean, we are going to subtract. When below the mean, when the given z-score is below the mean, to find the area below it, we are going to subtract the area given the z-score from 0.5000. So you can see it here. And we have the case number 2, when the z-score, or when we are asked to give the area above the given z-score. That is, we have greater than the given z-score or at least the given z-score. Let's have example number 3. Now, when the given z-score is positive or above the mean, we subtract the area from 0.5000 to get the area above it. While if the given z-score is negative, we add the area to 0.5000 to determine the area above it. That's the opposite when we have case 1, which is below the given z-score. And when we are asked to determine the area between two z-scores, we have to subtract or to add. We subtract when the two z-scores have the same or are located in both sides. It's either above the mean or below the mean. That is when the z-scores are both positive or both negative. But when the z-scores are located below and above the mean, that means one of the z-scores is negative and the other is positive. We add the two areas to determine the area between them. That is how we are going to determine the areas between two z-scores below a given z-score and above a given z-score under the normal curve. Thank you.